Alright, so thank you for joining me today. So my talk is basically designed for QA, because the conference is more a QA conference. But it will be actually very focused on dev and QA and BA, kind of the whole flow today. And then I would love to get all your feedbacks on how I can improve. This is a very raw version, so please give me feedback after that. Thank you. So what I'll be sharing today is shortening the customer feedback loop with feature switching. So if you think of feature switching in a very traditional sense or a very normal sense, something that consumers are aware of or used to, it's basically kind of like a house, right? You have your house with light switches, and you don't buy a new house just because you want one light switched on in a room. It's always going to be the same house, and you switch the lights on based on how and when you like it. So it's the same thing, same kind of idea we're bringing into software. So you can actually use feature switches to enable features in production or in your software when it's running. So first we'll discuss the importance of short feedback loops and why it matters. And then we will explore software development workflows that's popular today, and then a deep dive into what feature toggles are. So I'm going to use feature toggles and feature switching interchangeably. They're actually the same thing, just different terms. So if there's still anyone left in this room by the time I finish feature toggles, I will share with you how we used it in the Bumbleknots team, the partner dashboard accounting tab team, and then some implementation best practices that we have learned by making mistakes and learning from those experiences. So first, feedback loop. So this is a question that's really interesting, but I will not attempt to answer it and define it here. So what it is being agile. So how many of you here actually work for agile teams? Okay, so everyone knows what's agile? Yes? So this talk's not about agile, all right? And just a refresher, this is the Agile Manifesto, which is basically about individual interactions over processes, customer collaborations over contract negotiation, and most importantly, working software over documentation. This is an idea that's been brought forward by this guy called Joshua Karusky, who popularized the term modern agile. There's lots of cool stuff to read there, but I'm not going to focus on this. So it's basically a segue into covering the 4 values of modern agile in today's software teams, which is basically to make people awesome, continuous delivery, delivering value, making safety a prerequisite, as well as experimentation and learning rapidly. So the talk specifically today is going to be focused on this red triangle, which is to experiment and learn rapidly. So let me share with you a very old trait, but a very agile one. It's the trait of tailoring. And when I talk about tailoring, I will have to bring you to one place, which is Bangkok. So this is not Disneyland. Apart from its magnificent temple architectures and great street food, Bangkok is also very well known for its tailoring industry. So streets in Bangkok looks like this. There's a lot of tailors, very highly skilled, and you can get a full suit made for 250 New Zealand dollars. Right? And in just 3 days, you can get it all. So how do they actually do it? So your experience starts with going to a tailor shop. You choose what materials you want. You choose what kind of cufflinks and what kind of collars you want. And then you can even put your name on it if you want. All right? The guy measures you, takes all your measurements, and then sends it to a workshop. So after that, you go do some touristy thing, eat some nice food, and then you go back the next day. All right, he's going to give you a shirt that's almost like your size, with the same material, probably 1 or 2 sizes bigger, And what he's going to do is he's going to do this. He's going to basically size you up again, but very specifically taper the clothes so that's exactly made to fit. And then you go do more touristy stuff. And then you go back again on the third day and you get your perfect fit suit. So why am I telling you this story and how does it actually fit in the world of software that we live in today? So how is it possible when the people who actually make the shirt and the customers have never met? Kind of similar to what we are. We don't really meet our customers. Some of us have the privilege to, some of us don't. So if you look at the workflow, you start with a customer going to the store. Store manager takes measurements and send it to the tailoring team. And the store manager and the tailoring team gets back to the store manager with the product, who then presents it to the customer. The customer gives some feedback by saying it's too tight and all of that. Store manager takes that feedback, bring it back to the tailoring team. And once the tailoring team does the change that they need to do, they bring the idea back to, they basically bring the product back to the store manager, who delivers the final thing to the customer. Do you spot any difference here? No? There's actually a difference. All I did was replace store manager, product manager, tailoring team with development team, and that's the only thing I replaced. And I put our exact workflow into that exact template. So a customer interacts with the product managers or the UX team, and requirements are gathered, passed on to development team, builds it, pass it back to product manager, who then release it to the customer, get feedback, and eventually the product's there. So it's kind of very similar. And why is this important? Because experimentation is, so why is experimentation so important? Because customers seldom know what they want, but for sure they know what they don't want. And the best way to understand what customers really want is to consistently and rapidly experiment and learn. And of course, to be able to do it safely is very important. So there's two very popular terms that came out from in the software delivery world today, which is continuous integration and continuous delivery. So continuous delivery is the ability to get changes of all types, whether it's new features, configuration change, bug fixes or experiments, into productions or the hand of customers in a very quick, safe, and sustainable way. So with that, it breaks into the next segue of how do we actually achieve this continuous integration and continuous delivery. So let's first explore the most prevalent software development workflow tool called Git and Git branching. How many of you have used Git on GitHub? Cool. So the next 3 slides might be a bit too simple, but bear with me. So basically, this is what Git is. It's a version control system designed for tracking changes in computer files. And with Git, developers are able to create branches from trunk, sometimes known as master, to make their own localized change. So it's kind of much like a tree. You start with a trunk, and as the tree grows over time, you get branches. So this is a common setup in a project that is not going to move into the direction of trunk-based software development. You basically have lots of branches. You have master branch, you have hot fixes that happen even not in a branch, you have staging environment, you have dev or QA branch, you have feature branches. How many of you have worked in teams like that? Right, so almost everyone, right? So it makes it, this is very common when in teams that have many branch, you never really know where and what path a commit takes to go into production. And you get this extreme sometimes, right? So I'm going to now show you 2 truths and 1 lie. One of this is not a Git flow diagram. So, yes, I'm going to get a volunteer just to guess.
Just one. The left one.
The left one, yes. So the left one looks the most logical, but it's actually not a gate flow diagram. It's the diagram of the London train station, train system. And the right side, on the right side, those are actually visualization of gate flow diagrams in real world production systems. And that's way too complicated, right? So branches are not necessarily bad. I use them every day, right? And my team uses them every day. So what's bad about branches is that when they are long-lived. So if you have long-lived branches, you have many sources of truth. So it's kind of like a code base getting an identity crisis. Your cat thinking it's a cow and your cow thinking it's a cat. Very bad. Alright, so if you have code sitting on branches, it's not integrated. So if you have multiple sources of truth, then continuous integration becomes impossible. Wouldn't it be nice if it's just like that, one branch, everything gets back to the same branch and everything is very logical, you always know where to branch from? So then the cat's happy. The cat can be a cat. So how do we apply hotfixes without releasing features that are not yet ready for general release? So that brings us into our next segue, which is feature toggles or feature switching. So one thing to note, the preamble is as long as you introduce any feature toggles or feature switches, you are introducing technical depth into your code base. It's something that you have to remove one day, and based on what kind of toggles you use, it defines how long those toggles actually sit in your code base. So there's a big difference between deploying and releasing. Deploying means the code is in production. Deploying means the code path is available to users in production. So I can put a code in production without it being available to users. It's called the code's deployed. If the code's deployed into production and available to users, it's called the code's released. So there's 4 categories of feature toggles. They all have different usages and different meanings to it. So first we have release toggles, experiment toggles, followed by ops toggles and permission toggles. So I'll cover each of this in detail. So release toggles, what they do is they basically allow you to put code paths that are incomplete into production. So they are very, very transitionary by nature. You can actually hard code it because it's going to be short-lived. It will probably last 1 or 2 days or even 1 or 2 hours. So it's perfectly fine to hard code it. And anytime that you want to make change to this, you actually have to redeploy. Right? So an example is if you only have 1 branch and you have 5 developers, how do you all share the same master branch without conflicting with each other? Let's say you have to change a new feature. All right? You start with a very simple thing. You take an existing feature, an existing method, and then you put an if statement around the caller and say if true, then you just call that thing, which is existing function, and you just say if false, that's where you write your new thing. So therefore, you can actually still put new code without it ever being called. Right? So the next thing is experiment toggles. It's used for multivariate testing. So that means A/B testing. When you want to test user experiences or you want to test whether a new feature is basically going to kill your system by bad performance. So this is a technique that you can use for canary releases without having to change your infrastructure. Users are grouped into segments, and the key difference here with the next slide is that users are grouped by random sampling. So this is not beta users, these are users that are randomly selected. It's short to medium lifespan, so it lasts from hours to weeks, and toggle decisions are very, very dynamic. It happens in runtime, and therefore it has to be done in a way that you can actually change any of these experiments without having to change a single line of code. So for this to be implemented, you need to use a feature switching service that is something like Split.io or Launch Darkly to achieve this. Right? The third type is operation toggles. So these are things that are basically controlling the operational aspects of system behavior. So if you're familiar with the term chaos monkey, how many of you have heard that? Quite a few hands. So if you want to implement chaos monkey, ops toggles are very useful so that you can be able to degrade your system gracefully if one of your AZs is down, for example. So it's used when rolling out a new feature as well, when performance impacts unclear, so that you can quickly turn it off. It's usually short to long lifespans, depending. So it can range from just being up for days, or it can be there forever. Right? Let's say, for example, there are some toggles that, let's say you make a call to a third-party system, and let's say you want it to be there forever because let's say Facebook authentication is down. You want to be able to turn that feature off temporarily, even 5 years from now, right? So these toggles are very static. It's system-wide usually, but it requires a very, very fast turnaround time. So you cannot update config files to change this. Your web.config, because imagine if you have a ECS cluster which 5,000 instances, it will take you probably 2 days to change all the configs. So therefore you need a web-based configuration service, and this can be as simple as a JSON file sitting in an S3 bucket. And last but not least, you have permission toggles. So this controls your product experience for users. So if you are used to beta users or alpha users, this is the mechanism that we actually use for that purpose. So it's long lifespan, weeks to many years. It's not that we put the features in beta for many years. It means this segment of users is there for many years. All right? And toggle decisions are also highly dynamic, and it's done via a highly dynamic service, and can be used with things like feature switching services like split IO and launch darkly. So to summarize, this is basically a diagram that nicely summarizes the 2 dimensions, which is longevity and dynamism. So if something needs to be there for a long time and it's very dynamic, you probably need to use it as a permission toggle. If something is going to be there for a very short time, you probably need to use a release toggle. So things here changes with deployment, things on the other end changes by configuration of a web service that sits somewhere else. Is there any questions so far? So these are kind of like the 3 options you have right now. You have split IO, or launch darkly, or bring your own. That means code yourself. Right? So I guess since all of you are still here, I will talk about the next topic.
I have a meeting.
Okay. So feature toggles at NYB. So this is where I'm going to share with you what we do in the partner dashboard Bumblenots team. So this is not my effort alone. This is actually the effort of the whole team. And I'm just summarizing our learning. So the 2 types of feature toggles that we use are ops toggles and permission toggles. And what do we use to manage them? We use S3 and CloudFront for our ops toggles, and we use split IO and local storage for our permission toggles. So let me go more into detail with this diagram. So this diagram was drawn by Chris, and I basically just copied it. I mean borrowed. I'll return it to him after this talk. Okay, so this is our system. So what we built is the partner dashboard, and what it does is that basically it goes to the different systems in MRB like Essentials, ARL, Cashbook, which now all sit in Ledger Cache, to basically pull data, and it goes to like sales and billing and Archie as well. So we pull these services on a regular cadence in order to get data that basically updates the partner dashboard. The thing here is that this polling rate, it has to be dynamically set. Why? Because if we are polling too much, we need to be able to set to increase the duration of wait time without having to deploy. And if we want faster customer feedback, we need to be able to lower it down without having to redeploy as well. because these are configuration changes, not really code changes. So what we do for that is that we actually use an ops toggle, where we use S3 to put a JSON file in there, and this thing actually just posts that JSON file all the time. All right, and one thing about S3 is that you can't do HTTPS. So what we wrapped around it was basically CloudFront, so that you can attach a SSL cert to it, so that you do not face cross-origin issues. But if you don't need SSL, then that's fine. You can just use S3 Assist. Okay. So another thing that we do is that we have features that we actually release to users in alpha and beta stage. So alpha are people who are internal, so like our product managers are in the alpha segment, and our beta is beta customers. So what we do is that we actually wrap it around this thing, a Split IO SDK, and it's used both in our front end and our back end. And when a new feature is developed, it's always if feature is enabled, do this new feature, or else runs the old feature. And every time you'll basically go in and clean up the code. So another innovation that the team did recently was we actually used local storage to allow users to do self opt-in into a beta program. And that basically, when a user says, I want to be in, the flag is actually set in your local storage. So that's an interesting thing, because you actually have no access to that storage at all, because it's on the user's machine. But that's fine, because we don't really need to control that, so that we want the users to be able to control that settings themselves. So next, I'll talk about some of the implementation best practices. So we're actually quite ahead of time. So some of the best practices that we learned is to basically that you have to set up feature switch traffic monitoring dashboard. So that, let's say for example, if you run feature switches, you want to have a dashboard so that you know how many % of your traffic is going to the new flow and old flow, so that if something goes wrong, if like a lot of traffic goes to your new flow which you're not expecting, you know that there's something wrong with your new feature switch service. Because ultimately feature switch logic, the if and else, is written by human beings, and therefore you can have bugs as well. Right? You can't test everything, right? If you write a unit test for your code, you will not write a unit test for your unit test. So there's going to be a limit where you test. So dashboards with key business metrics are also important, because you want to observe if the most important thing is in your system is if you introduce a new flow, are more customers coming in and completing a particular flow that they are previously using. If you talk about e-commerce, if you launch a new feature, sales goes down, that feature is bad. Right? Another lesson we learned is to avoid feature switch nesting. So don't nest a feature switch in another feature switch, because if you turn one on and the other one accidentally gets turned on or turned off, that's not ideal as well. It becomes hard to manage. Avoid coupling your decision toggles with your decision itself. So for example, if you have a statement that says if condition do something, else O code flow, this logic here should be abstracted out into another service. So this if statement should not actually have to say if user is Mark, do something. All right, that decision should be somewhere else. Okay. And cache configurations are better for scalability. So let's say this thing goes to poll a service all the time. The poll should not actually happen every time this if statement is called, but rather it should call a singleton or a local cache, so that that setting is stored locally and probably refresh every minute or something, so that your system can actually scale. Or else you're inevitably doing a DOS on your feature switch service when you have a lot more users. All right, so this is the last slide. So some of the key takeaways are trunk-based development is a requirement for continuous integration. Feature switches allows team to deploy unreleased code. Feature switch are technical depth by design, and always use the right tool for the job. There's 4 different types of feature toggles, each have different characteristics and different implementation best practices. So if you use a feature switch service for ops toggle, you're probably going to pay a lot more than you need to when your bills come. Right? S3 is always going to be cheaper than split IO, for example. Do not use decision points with, so do not couple decision points with toggle routers, and do not nest feature switches. So these are, if you can't remember anything else, these are the more important things. So with that, that's all. Okay.
So we've got time for a couple questions.
Yep.
So maybe we take 3 questions, and then if there's any questions after that, they can just stay.
And please let me feedback. That's my main objective here. Okay. It's here, bro.
So for the feature toggles, right?
Yes.
You're saying that you guys use S3.
We use S3 for ops toggles.
Oh, pardon. So how does that sync with your environment? Like you keep hitting S3 for each request, or like?
So currently, you are right. We are doing it in a not ideal way, which is we hit S3 per request, per refresh. That's not ideal. We are willing to live with that cost because S3 is very, very cheap. But if we are doing that onto split IO, which is a lot more expensive, at least 10 times more expensive per request, then probably we will not do that. Yeah. So on split IO, we actually use the split IO SDK, which actually has this built-in thing that caches the settings locally in a singleton pattern lifecycle, both for the front end and back end, and it refreshes the back end every 1 minute. It validates the state. Thanks for your question.
Cool. Okay. Well, thank you just one more time, Darren, for preparing the talk and presenting it. And if anybody does have any questions after, just hang back. But just once more, thank you very much.
If you guys want to see how we implement it, feel free to come by our mobbing station.